This is your Broden-Bacqua phosphate. This is your Broden-Bacqua phosphate. And today we have much work to do. We don't really have time, so we are going directly to our work. Welcome to Bacqua Phosphate Academy. You can receive your lectures at any time with Bacqua Phosphate depending on your program or work. We are available at any time for you. You just need to reduce the time you spend chatting with your friends on social media, and Bacqua Phosphate will teach you chemistry right in your home room. I am ready to work with you one-on-one to help you become an expert in chemistry. The classroom is brought right to your room. Take your notebook, pens, calculator, pencils. Let's start working. Lecture 1, Part 1, Physical and General Chemistry. The topic 1 is the mole concept. M1, Introduction and Definition of Terms. Question 1. Define the following terms as used in the mole concept. We have the amount of substance, B, the mole, C, the Avogadro's constant, L. You have to put down your answers, then we check whether your answers are correct. Items in our everyday life are counted using counting units such as a dozen to represent 12 of a particular item. So you have 12 eggs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 eggs equal to a dozen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A dozen of mangoes is equal to 12 mangoes. So in our ordinary day life, we use a dozen to represent 12 of a particular item. Elementary particles, atom, molecule, ions, protons, neutrons are very small or tiny. The counting unit in chemistry that we are going to use is called a mole. So just like we can count mango, we can count pen, biscuit, we cannot count elementary particles. So we use a unit of measurement in chemistry. Unlike a dozen in mathematics, we use a mole to count the number of particles. So we say the amount of atoms in exactly 12 grams of carbon-12 isotope was chosen as a standard because 1. So we are going to use a standard, which is carbon-12, the number of carbon atoms in 12 grams of carbon-12 isotopes. So that standard has a name called the Avogadro's constant. The number of carbon atoms in exactly 12 grams of carbon-12 isotopes is called the Avogadro's constant. So, but we use the carbon-12 scale. Why? Number 1, the carbon-12 isotope is very stable. The carbon is a very common element. Carbon is very common. Being a solid, it is easier to store and transport. Note, on the carbon-12 scale, atoms of the isotopes carbon-12 are assigned a relative atomic mass of 12. Let's study the picture of rice and corn flour below. Can you imagine how many grains are there in each plate? You were to count the number of rice grain here, or you were asked to, another student asked to count the number of corn flour. You realize that it will be very difficult to count, especially for the corn flour. Now imagine how to count particles. Particles are microscopic. You are dealing with atoms, molecules, protons, neutrons. You can only use a microscope to get them, to see them. So it's difficult to count them. So we count a collection of these particles. In chemistry, we use a unit of measurement called the mole. And just as a dozen represent 12 of a particular item, a mole of any substance must contain the Avogadro's number of particles. A mole of a substance must contain the Avogadro's number of particles. A. Amount of substance is the measure of the number of particles in a substance or the number of moles of the substance. When we talk about particles, it could be atom, molecule, protons, electrons, neutrons. So the amount of substance is the measure of the number of particles present. How many particles are present is the amount of substance. How many number of moles are present is the amount of substance. So you check whether your answer is correct. B. The mole, N, is the amount of substance that contains as many elementary particles, atoms, molecules, ions, protons, as there are atoms in exactly 12 grams of carbon-12 isotopes. In exactly 12 grams of carbon-12 isotopes. You are comparing the number, that amount of substance. So if there's a certain amount of substance which has the same number of particles, elementary particles, which is equal to 6.02 times 10 to the 23 sodium atoms, or 6.02 times 10 to the 23 chlorine atoms, or 6.02 times 10 to the 23 chloride ions, we say that that is a mole of a substance. Why? Because it contains the same number of particles as there are carbon atoms in exactly 12 grams of carbon-12 isotopes. The number of carbon atoms in exactly 12 grams of carbon-12 isotopes is said to be the Avogadro's constant. The actual number of atoms in 12 grams of carbon-12 is experimentally determined to be 6.02 times 10 to the 23 carbon atoms. This number is called the Avogadro's constant. Unit is per mole. C. The Avogadro's constant, L, is the number of carbon atoms. Is the number of carbon atoms in exactly 12 grams of carbon-12 isotopes, or it is the number of particles in 1 mole of a substance. It is the number of particles in 1 mole of a substance. So the number of carbon atoms in exactly 12 grams of carbon-12 isotopes is called the Avogadro's constant. Atomic mass, relative atomic mass, relative molecular mass, molar mass. Can you just put down your answer before you check if your definition is correct? So define these terms and let's see whether you are correct. Write down your answers before you check if your answers are correct. By comparing your own answer with the teacher's own, you will see whether you had it correct or not. Welcome back. Let's see if you had it correct. You must not be coming up here to compare your own answers. Remember, we are a bit fast here because these are things we have already done in the other videos, but for the sake of analyzing and going the way we want to program this channel to go now, we have to repeat all what we have been doing before now. D. Atomic mass. What do we call atomic mass? This is the mass of an atom of an element in atomic mass unit. So the mass of an atom of an element in atomic mass units is said to be an atomic mass. AMU, which is atomic mass unit, is the mass which is exactly equal to 1/12 the mass of a carbon-12 atom. Exactly. So when you take the mass of a carbon-12 atom and you divide it by 12, it gives you 1 atomic mass unit. So we can look the atomic mass of an element with different isotopes. For example, when we have M1, M2, and the different fractions F1, F2, or M3, F3, we can sum all of them, the summation of MF, where M equals to mass of an isotope, F equals to fraction in which it is present. For example, so mass is equals to M1, F1 plus, you can see the case of chlorine. For example, chlorine is made of 2 isotopes, chlorine 35 and chlorine 37. Each of these isotopes exists as 75%, 25%. So what is the atomic mass of chlorine? You see that the atomic mass of chlorine, you take 35 times 35 on 100, that will give us a fraction in which chlorine 35 will exist, and then you take 37, which is the mass, number times 25 over 100, which is 35.5 atomic mass unit. To avoid the use of non-SI units, so you see you can calculate, if an atom has 3 different isotopes, you need to get all their ratios and multiply by their masses, and we are going to get their atomic mass. And when we express it in atomic mass unit, it means that we are comparing it to the mass of 1/12 that of a carbon atom. But chemists don't always use atomic mass unit. We avoid it. So to avoid the use of non-SI unit, we need now to think about relative atomic mass instead. So we say it is conventional to quote the atomic mass of an element, not in atomic mass unit, but as the number of times it is greater than 1/12 of the mass of a carbon-12 atom. The number of times it is greater than the 1/12 of the mass of a carbon-12 atom. This quantity is known as the relative atomic mass. So what do we call the relative atomic mass of an element? The relative atomic mass of an element is the number of times the average mass of one atom of the element is as heavy as 1/12 the mass of one atom of carbon-12. So relative atomic mass will be equals to average mass of one atom of the element over 1/12 of the mass of one atom of carbon-12. So you are comparing the number of times the average mass of one atom of the element is heavier than 1/12 the mass of one atom of carbon-12 isotopes. We say that's the relative atomic mass of the element. Similarly, the masses of molecules, ions, and all other small particles are expressed as ratios and referred to as relative masses, e.g. relative molecular mass for molecules. So relative molecular mass for molecules. You simply see the relative molecular mass of a substance is the mass of one molecule relative to 1/12 the mass of one atom of carbon-12. So you see, it is the number of times that one molecule of the substance is as heavy as 1/12 the mass of one atom of carbon-12. So relative molecular mass equals to mass of one molecule of compound over 1/12 the mass of one atom of carbon-12. That is what we call the relative molecular mass. So we say that relative molecular mass is easily computed. We can calculate the relative molecular masses of different elements or compound given to us as the sum of all the relative atomic masses. So molar mass is simply the mass of 1 mole of a substance. The mass of 1 mole of a substance. So for the sake of us not spending much time in this particular video, I'm going to complete this video 1 in the next video. So this lecture 1 will be in 2 sections. So you have to follow up. This is what we're supposed to do. I want to conclude this video and then you move on to watch the other video just for us to easily upload our video. It was good working with you. Thanks for spending time with Backward Phosphate Academy. Hope you did enjoy the lessons. If you did, consider subscribing to our channel so that when new lessons come up, you will be notified. We would like to know how you feel about this lesson. Leave a comment in the comment section. Backward Phosphate Academy is an online teaching platform and ready to help teach you any topic in chemistry. Contact us at backwardphosphate@gmail.com. Join us backwardata@ymail.com. 679953185, 6644632576, 677832852. Thank you.